Hello everyone, welcome to ME400, Vibrations and Acoustics. So in order to start off with vibrations, we really need to have an understanding of complex numbers. So I'm going to do a couple of videos on just basic complex number operations. So right here we'll start with addition. So we have these two complex numbers in the imaginary form of a real part and an imaginary part. So to add these together is really pretty easy. You take x1 plus x2, put them together and you go 1 plus 2i plus 3 minus 4i. And you can do it straight like that, and then you basically look at it as common denominators or common multiples or common variables. So the i's you consider a variable, and you can just add them straight across like this. So if you do this, this will equal 3 plus 1 is 4, and then 2 minus 4 minus 2i. And that's a solution right there. You can use that as a way to add the multiples. But if you need to take this a step further, and get it in the form of A, E, I, or theta, so Euler's, in the Euler's form, then you can carry this on a little bit further, and what it is x bar, or x hat, whichever one you want to call that, x1 plus x2 is equal to A, E, I, theta, which is then equal to A cosine theta plus A, I sine theta. So this is Euler's equation, basically, or Euler's identity, whichever one you've been shown it as. And basically this is a conversion from trigonometric units to basic numerical units and exponents. And in order to solve this out and get it down into this form, because this is where we finally want it, this works if that's as far as your instructor wants you to go, but if you have to take this a step further and get it into this form, you have to find A is equal to the square root of 4 squared plus minus 2 squared. And what I did right there was I took the number 4, put it down in here, squared it, and then minus 2i down here and squared it, and put it under this under the root symbol. And you can recognize this as Pythagoras' theorem, because if you're looking on a chart and you have some vector, you have the imaginary part and the real part, then you have the imaginary component of it right here and the real component of it right here. So a squared plus b squared, square root of it, gives you the amplitude, basically, which is the length of this vector. So that's where this comes from. Okay, and then theta of this vector is equal to the arctangent, or inverse tangent, whichever one you want to call it, of minus 2 over 4. And again, you can reference this for this kind of stuff, SOHCAHTOA, which is then going to be equal to, I'm going to go ahead and move down here, 0.464 radians, which is also equal to negative 26, oh sorry, that's a negative 0.04. Alrighty, negative 26.565 degrees. But usually when you're working in vibrations, you always want it in rad, so this is the one you care about. So then in standard form, x hat is equal to 4.472, because that's the result of this. Sorry, I didn't put that up there. 472. That's the amplitude. E minus I times 0.464. I'll put a 0 there in front of it to make it a little bit clearer. And that's your final answer. So both of these work. This is also equal to x hat. They're just two different forms of it, if you want it in imaginary or in Euler's form. And that's how you add complex numbers.